Bismillahirrahmanirrahim. Here we will discuss the technique of integration which is known as substitution technique. Uh, we earlier discussed this technique in early classes like in first year or second year, but now here we will give a short overview of this technique. In this technique, if we have the question of this pattern like square root a square minus x square or 1 over square root a square minus x square, we have a substitution x is equal to a sine theta. Similarly, if we have 1 over x square, 1 upon square root x square minus a square or square root x square minus a square, we take x is equal to a secant theta. Similarly, a square plus x square or 1 over a square plus x square or square root a square plus x square or 1 upon square root a square plus x square, we have x is equal to a tan theta as a substitution. To describe these techniques, I can just take only one question and simplify. Although this is not the topic for BSc, but to solve few questions, we use this technique. So here we have in exercise 4.1, question number 10, 11 and 12, and I have selected question number 10 as I is equal to square root 4 minus x square. I think instead of solving this particular question, I will solve a general formula which is equal to I is equal to integral square root a square minus x square dx. Here we have the substitution for this type of question as x is equal to a sine theta and dx is equal to a cos theta d theta. Now put these two values in this equation number 1. After putting these equations, we have a square minus a square sine square theta and uh, uh, put the value of dx as a cos theta d theta. After simplification, here we take a square as common and get 1 minus sine square theta into a cos theta d theta. As we know that 1 minus sine square theta is equal to cos square theta. So put the value of 1 minus sine square theta in above expression and get a square into cos square theta and already have a into cos theta d theta. Now a square cos square theta will simplified with the square root and we have a cos theta into a cos theta d theta. A into a is equal to a square, as a square is any constant term, so we can take this constant term is outside the integral and we left only with cos square theta inside the integral. So as we earlier discussed that cos square theta can be solved by putting 1 plus cos 2 theta upon 2. So put the value of cos square theta which is equal to 1 plus cos 2 theta upon 2 in above expression and got this expression as 2 is constant. So we take 2 outside the integral and we have only two terms inside the integral which are 1 plus cos 2 theta. So after integrating 1 we have theta and cos 2 theta, we have sin 2 theta upon 2 plus c. Now put the value of sin 2 theta which is equal to as sin 2 theta is equal to 2 sin theta cos theta. So put this formula in above expression and we have 2 sin theta cos theta, cancel out 2 with 2 and we are left with a square upon 2 into theta plus a square upon 2 sin theta cos theta. Here we take back substitution. Now I will express and write in detail the method of back substitution. The method of back substitution will start where we start substitution. As we start substitution by taking this expression x is equal to a sine theta. So we take a in the denominator of left hand side, so x over a is equal to sine theta. As in early classes we remember rem for remembering trigonometric expressions, which is some people have curly brown hair, through proper brushing. And we use this expression sine theta is equal to perpendicular over hypotenuse, and write this expression in right angle triangle x upon a, and after applying Pythagorean theorem, which is equal to hypotenuse, because square of hypotenuse is equal to square of base plus square of perpendicular. So here we will find the expression for base, which is equal to a square minus x square along with square root. So sine theta is equal to x over a, and we get here we can get the value of cos theta from here, which is equal to base over hypotenuse, that is equal to a square minus x square upon a. Now put the value of sine theta and cos theta, also the value of theta, in expression number 2. Here we will get the value of theta like sine inverse of x upon a is equal to theta. So put all these values in expression number 2. We will have sine inverse x over a plus a square upon 2 sine theta is equal to x over a, and cos theta is equal to a square minus x square square root of a square minus x square upon a. A square over 2 sine inverse x over a. After simplification we will cancel out a into a, which is equal to a square, and we have x upon 2 into a square minus x square. Now if we discuss question number 10, question number 10 is equal to 4 square root of 4 minus x square. If we take 4 as square root of 4 as square of 2 minus square of x. So for question number 10, put the value of for question number 10, take a as 2 or a is equal to 2. So we have square of 2 upon 2 sine inverse x upon 2 plus x upon 2 square of 2 minus x square. After simplification we will have 2 sine inverse x upon 2 plus x upon 2 into square root of 4 minus x square plus constant of integration. Here we forget to write c. Now this completes the result. In this way we will solve generally for question number 11 and 12, and we will solve these expressions as well for some other questions. Here we have another question of exercise 4.2, which is I is equal to integral 1 over x square minus a square along with square root. So we take a substitution x is equal to a secant theta for this particular question, and dx is equal to a secant theta tan theta d theta. Put all these values in this expression. We have I is equal to a secant theta tan theta d theta, and a square secant square theta minus a square. After simplification, if we take a square as common, we have secant square theta minus 1, which is equal to tan square theta, and the expression above And the expression above denominator is written as a secant theta tan theta d theta, and we will simplify square root a square tan square theta as a tan theta. Now cancel out a and tan theta. We have only secant theta d theta left in this expression. After apply the formula for integration on this expression, we will have log of secant theta plus tan theta plus c. Now it's a complete solution of above expression with theta. So as the original question is given in the form of x, so we will move this question in original form. So we will take a back substitution as as we have x is equal to a secant theta is our original substitution. X over a is equal to secant theta and a upon x is equal to cos theta. By using a previous method, we can complete a right angle triangle which is equal to cos theta is equal to perpendicular over base over hypotenuse. So we have a upon x written in right angle triangle, and by using Pythagorean theorem we have x square minus a square right here. So here we get the value for expression tan theta is as perpendicular over base. Put the value of perpendicular and base, and we have the value of tan theta. So put the value of tan theta and secant theta in expression number 2, and we get log of secant theta is equal to x over a plus tan theta, which is equal to x square minus a square upon a plus constant of integration c. Now simplify this expression. We can write it as x square minus a square upon a plus c. By using the techniques of logarithm, we have a log of x plus square root x square minus a square minus log of a plus c, as c is the constant and log of a is also constant. So instead of writing both expressions, we will write only a single constant instead of these two terms. This is the final solution. You can stop this question here, or you can stop this question here. Both are the complete solutions for this question.